For as long as we've gazed into the void between stars, one question has haunted every discovery. Just how vast is the cosmos we inhabit? Generations believed they had glimpsed its edge, only to find the boundary receding further with each new eye turned skyward. In its relentless pursuit of the infrared unseen, the James Webb Space Telescope has shattered expectations once more. It has uncovered a universe not merely deeper, but fundamentally larger, crowded with galaxies in numbers, and at epochs that force us to redraw the very map of existence. A single sweeping survey has revealed nearly 800,000 galaxies in a patch of sky once thought sparse, galaxies that blaze brightly when the cosmos was barely an infant. This is not refinement. This is revelation. The observable universe stretches farther, contains more, and began its intricate dance of structure sooner than any model dared predict. To feel the weight of this shift, recall the foundation we once stood upon. Hubble's deepest gazes, like the ultra-deep field, pierced the darkness for days and returned with thousands of galaxies, enough to inflate estimates of the total to hundreds of billions, perhaps trillions. Yet Hubble peered primarily in visible light, blind to the stretched infrared signatures from the most remote eras. Webb changes that equation entirely. Its enormous mirror and cryogenic instruments capture wavelengths Hubble could never reach, seeing through obscuring dust and across cosmic expansion that reddens light beyond recognition. What emerges is not a modest extension of the old view, but a transformation so profound it redefines scale itself. Consider the Cosmos Webb field, the most ambitious deep survey yet undertaken with Webb. Over 250 hours of exposure time, thousands of frames stitched into a seamless panorama covering an area roughly 3 full moons wide, yet still a mere pinpoint in the sky. The result? A catalogue of nearly 800,000 galaxies, spanning from the present day back to within a few 100 million years of the Big Bang. If Hubble's iconic deep field were a single page in a book, this Webb mosaic would sprawl across an immense wall, dense with detail no previous instrument could capture. For the first time, we hold a continuous chronicle of cosmic evolution in one frame, tracing how galaxies formed, merged, and matured across nearly the entire 13.8 billion year history. And the surprises cascade immediately. This is not a quiet, gradual unfolding. The universe teemed with activity far earlier than anticipated. Galaxies appear in staggering abundance at redshifts once considered frontier territory. Bright, luminous objects, some 100 times more numerous than pre-Webb theories allowed, light up the cosmic dawn. These are not faint, tentative flickers. They are massive, chemically enriched systems already forging heavy elements through generations of stars that lived and died in what, cosmically, amounts to an eye blink. Push deeper, and the revelations intensify. In fields like JD's, Webb has confirmed galaxies existing just 280 million years after the Big Bang, the current record held by MOM-C14. A remarkably luminous and compact galaxy with a redshift of 14.44. Its light, stretched across 13.5 billion years of expansion, reveals a system far brighter and more evolved than models predicted possible so soon. Carbon, oxygen, nitrogen, the fingerprints of multiple stellar generations, already permeate its gas. The universe did not wait patiently for structure to emerge. It erupted into complexity with ferocious speed. This accelerating maturity extends beyond isolated galaxies. Webb, combined with Chandra's X-ray gaze, has uncovered protoclusters, vast assemblies of galaxies, forming when the universe was only about 1 billion years old. Structures with masses reaching 20 trillion solar masses, harboring dozens of members bound by gravity and bathed in hot gas, appeared 1 to 2 billion years ahead of schedule. What were once thought to be late-stage phenomena, the colossal scaffolding of superclusters, began coalescing in the cosmic toddler years. Gravity worked overtime, pulling matter together with an urgency that defies slow and steady simulations. Even the invisible architecture reveals itself more clearly. Detailed maps of dark matter, sharper than ever before, show how this enigmatic substance sculpted the visible universe from the start. Clumps and filaments concentrate ordinary matter, birthing galaxies in precise alignment with the underlying web. Webb's infrared precision doubles the resolution of prior efforts, exposing finer details of how dark matter gathered gas and stars into the first luminous knots. The framework was in place sooner, denser and more influential than expected. These findings ripple outward. The sheer number of early galaxies, far exceeding forecasts, implies star formation rates and efficiencies that push theoretical limits. Supermassive black holes appear embedded in these infant systems, growing at rates once deemed implausible. Mergers of multiple galaxies occur in tight, chaotic dances just 800 million years after the Big Bang, redistributing elements across intergalactic space. Quenched galaxies, those that have already exhausted their star-forming fuel, surface earlier than models allowed. Spiral structures emerge in systems barely 1 billion years old. The cosmos did not evolve gradually. It surged forward in bursts of creativity that leave our timelines in disarray. This is why Webb's vision matters so profoundly. It exposes a universe larger not just in extent, but in richness and rapidity. The observable sphere, already vast at 93 billion light-years across due to expansion, now brims with trillions upon trillions of galaxies, many born in an era when conventional physics struggled to explain their existence. What we once called the edge of possibility has become a crowded foreground. The early universe was not sparse and silent. It was vibrant, violent, and precociously advanced. We stand at the threshold of a new cosmic narrative. Theories refined over decades must now accommodate this accelerated growth, perhaps through unknown efficiencies in star formation, direct collapse black holes seeding giants swiftly, or mechanisms yet unnamed. The universe grew up faster, filled itself more densely, and structured itself more boldly than we imagined. Every new record broken by Webb, every deeper field, every higher redshift, pushes the horizon farther and fills the space behind it with wonder. And yet, for all its breathtaking scope, this vast tapestry remains only a glimpse. The Cosmos Webb mosaic, the largest ever crafted, covers a fraction of the sky. Beyond its borders lie uncharted depths, countless more galaxies waiting in the infrared shadows. We are the first witnesses to this fuller, stranger reality, a universe that refuses to be contained by expectation. What does it mean that the cosmos proves so much more immense, so much more alive from the beginning? That in peering farther we discover not emptiness, but abundance beyond reckoning? The James Webb Space Telescope has not merely expanded our view, it has expanded our sense of what is possible. The universe is bigger than we thought, deeper than we dreamed, and still unfolding secrets we are only beginning to grasp. If this journey through the newly revealed cosmos has stirred something in you, the awe of scale, the thrill of mystery, then carry it forward. Subscribe to join the ongoing exploration as new discoveries arrive almost daily. Comment below with your thoughts. Does this accelerated universe change how you see our place in it? Share this video with someone who needs to feel the scale of existence tonight. Because the more we look, the more we realize. We are part of something incomprehensibly grand, and the story is far from over.